Good morning, everybody. Welcome back to my session on programming with objects. I am Anusha of CSC Department, Institute of Aeronautical Engineering. I'll be covering the subject programming with objects based on Java. So, in the previous class, we have discussed about inheritance, the different types and hierarchies of inheritance, what are super and subclasses, how these can be accessed. Now, in today's class, we'll be discussing the importance of final, and then object class and polymorphism. So, what is the importance of final keyword? Final keyword is mainly used on to create constants if they are applied over variables. Constants if they are applied over variables. So, if we want to define any variable, we can, if we want to define any variable as a constant, then we can use final keyword just before the declaration. Like how we have final int a is equal to 10 means you are declaring a variable of integer type which is a constant. So this value will remain 10 throughout the program. Now, that is first use. Now, if we apply it over any method, then that method cannot be overridden. It cannot be overridden. That means you can, if any method is being declared as final, then the implementation of that method cannot be changed in the lower classes, in the child classes. So that is another use. And third use is that if we are using the final method, a final keyword over a class, then you cannot inherit that class. So these are the three main uses of final: to create constants, to prevent to stop overriding methods, and to stop inheritance. So how we can use? We'll just look into an example. So we have a class defined, and we have a method named meth inside the class. So we are declaring this method as final void method. That means this method is declared as a final. So if we are declaring any method as final, then you cannot override that method in its subclass. So in this method, we are printing some statements. Now we are from class A, you are creating another class B. You are inheriting class B from class A. So now, if while inheriting, we have the ability to change you have the ability to override the methods in that. So if we try to override the method which is available in the parent class, which was declared as final, then the JDK will throw an error. So this the implementation, the overriding of any method, any final method is not allowed in Java. So if you want to stop any method being overridden, then you can use final as, you can declare that method as final. Now, if we use final over a class, then that class cannot be inherited by any other class. So if we make any class as final class, then it cannot be inherited. And also, if we declare a class as final, all of its method will be final. So you cannot override that class. So using final over class prevents inheritance, and you cannot declare a class both as abstract and final. And because if we are making use of abstract class, then you have to override that method which is defined inside the abstract class. The abstract method inside the abstract class must be overridden. So you cannot declare both abstract class, and you cannot declare a class both as abstract and final. So when you declare any class as final, then it prevents inheritance. So from a final class, you cannot extend another class, which is illegal. So this is the three main uses of final keyword. If you are applying final keyword over a variable, then you are creating constants. If you are applying it over method, then you prevent overriding. You prevent method overriding. And if you apply it over classes, then it prevent inheritance. Next is object class. So what is an object class? This object class is the superclass of all classes in Java. It is the topmost class in the hierarchy. All other classes are all the other classes will inherit by default. They will inherit the object class in Java. So you can, because of which you can use the reference type of the object class to reference variable of the object class to refer any object of the other class, since it is the superclass of all other classes. Now there are a lot of methods which is available in the object class, which can be which some are declared as final and some are not final. So all these methods will be inherited by it can be accessed by the other classes. All these methods will be by default available in any class you create in Java. So these are various methods. So the clone method is used to create a new object that is the same as that of object being cloned. So if you want to create a clone of an existing object, then you can use the method clone. Then equals method is used to check whether two objects are equal or not, whether one object is equal to another. So the equals object determines whether one object is equal to another. Next, you have the finalize method. It is used before any unused object is recycled. So we have already seen this finalize method, wherein it is mainly used at the time of garbage memory reallocations and during garbage collection. So it is called before an unused object is recycled, so that it can release all the resources held by that object. Then we have the get class method. The get class method is used to obtain the class of the object at runtime. So if you want to determine any class of a particular object, then you call get class method. Then the hashcode method is used to return the hashcode associated with that corresponding object. If you want to get the hashcode corresponding to that object, then you call the hashcode method. The notify method is it is mainly used during inter-process communication. So wherein it resumes the execution of a thread waiting on the invoking object. So if you want to if you want to resume the execution of a thread which is waiting for another, then you can call the notify method. The same way we have notify all method, which resumes the execution of all the threads waiting on the invoking object. So if you call notify all, then all the threads which is waiting for an object can be resumed. Then the toString method is used to return a string that describes the object. To return the string what describes the object, we use the toString method. Then we have the wait method, which is used to wait on another thread of execution. So there are three overridden methods of wait, wherein it has you can specify without any time, with some time, which is represented by milliseconds, and with milliseconds and nanoseconds. So these are the various methods which is available inside the object class. Now, of which the get class, notify all, and wait, these methods are all final. So since they are final, they cannot be overridden in the child class. Whereas the other methods, mainly the toString method and the get class method, the equal method, they are all they are not final methods, so you can override those method according to your implementation requirement. So this is object class, wherein the object class is the parent class of all the classes in Java. Polymorphism is the ability to exist in more than one way. So we have already seen two types of polymorphism. One is overloading, which we have already discussed, and the second type is overriding, which we will discuss now. So overloading is also called as ad hoc polymorphism, or they are static polymorphism. So this happens at the time of compile time, whereas overriding is runtime polymorphism, or they are also called as pure polymorphism. So these two types of polymorphism is available in Java, wherein overloading happens at the time of compile time, and whereas overriding occurs at runtime. Now, overloading means overloading happens when the methods have same name but different signatures. That means the parameter passed to it will be different in case of overloading. But in overriding methods, when it comes to pure polymorphism, the methods as well as the signatures will be the same. That means the number of parameter and the type of parameter passed will be the same in overriding, method overriding. And they will be, all the methods will be of the same name. So this is this overriding method is the implementation of one interface, multiple methods aspect of polymorphism. It is also the one interface, multiple methods aspect of polymorphism. So here the method, this happens when at the time of inheritance, mainly when we have two classes. The method in A, let's say we have a method named meth in A. This method is having, let's say, single parameter being passed. Let's say we are passing a parameter. Now the same method will exist in B also with the same name. The name is the same and the signature is also the same. So how will we determine which method has to be invoked? So in case if the method is invoked in the child class, so let the method be invoked from the child class, then that particular method will be invoked. The method which is defined inside the child class. That is, when an overridden method is called within its subclass, then it will always refer to the method defined by the subclass. So in method overriding, they will be having the same name and same signatures. The same signatures will be present. So here the child class method is overriding the parent class method. The child class method is overriding the parent class method. And now if you want to access the parent class method from the child class, then you have to make use of the keyword super. We'll use the keyword super to invoke the parent class method of the parent class version of that particular method. Now let's look into an example of runtime polymorphism or overriding. So we have a class named A. This is the parent class. From this, we are extending the child class A2. We are having the parent class and we are extending the child class. So inside A1, we have the constructor which is initializing the instance variable of I and j to 10. Inside the constructor, the values of I and j are initialized to 10. The I and j are instance variables of class A1. Now we have the show method defined, which is printing some statements like this. In A1 we have I and j. So this is how the show is implemented inside A1. Now we have the class A2 which is inherited from A1. The class A2 is inherited from A1, wherein A2 is for A2, it is having its own instance variable k. Since A2 is inherited from A1, it will also have access to I and j and the show method, right? So inside the constructor of A2 is initializing the values of I, j and k to 20. So these are the instance variables of A2 now. Now the same show method is overridden inside the class A2. So here we are changing the implementation of A2, wherein we are simply printing the contents of I, j and k. I, j and k are being printed. So this is how we have the show method being overridden of the parent class, show method of the parent class being overridden by the child class. Now let's see how we will invoke it. So here we are in this class, in this another class, the testing class, we are creating an object of it. So we are creating an object of it. Of whose object we are creating? The object of A2, the child class. We are creating the object of A2, named A2, and we are invoking show method of A2. So since this show method is called over A2, it will invoke the show method which is present inside the child class. So because of which you get this statement. In A2 we have values of I as 20, because here inside the constructor we have set the values of I as I, j and k as values of I, j and k as 20. So since A2 is calling show method of the show method, it will invoke the child class version of show. So you get I, j and k as 20. So here we have the class A, parent class A, A1 and child class A2. Inside parent class you have the show method, and inside the child class the show method is overridden in its own way. The show method is the implementation of show method inside the child class is different. So when the invoking of show method based on which object is invoking the show method, that particular method will be invoked. So here we are using the child object to invoke show, so it will invoke the show of child. Next is dynamic method dispatch. This is one of the important feature and powerful concept of Java, and it is achieved because of method overriding. So it is the dynamic method dispatch is the mechanism by which a call to an overridden method is resolved at runtime rather than compile time. So we have already seen that, wherein we have one object of based depending on the object invoking the method, that particular version will be invoked. So we'll look into detail of that. And this is by DMD or the dynamic method dispatch. It implements runtime polymorphism. So it allows and because of this polymorphism, we can Java allows to declare a base class which is generic, and from the generic base class we can derive from generic class we can derive more specific implementation of the subclasses. So in the base class we may give some generic definition of the class, whereas in the subclass we will derive the subclass will be having more specific implementation according to its need. So the polymorphism allows the general class to specify methods that will be common to all its derivatives, while allowing the subclass to define the specific implementation of some or all of those methods. So because of this polymorphism, we are achieving code reuse and robustness in Java. So let's look into another example. Here we have the class called as dispatch, and we have three classes: class D, class E and class F. The class D is the parent class. Class D is the parent class with a method named callMe. That callMe is implemented in this way. It is simply displaying some statement saying that it is inside D's callMe. So callMe have one type of implementation inside D. Now from D, two classes are inherited, class E and class F. So we have D class. From D we have E and F derived. So inside E, callMe is overridden in its own way, which is displaying it is inside E's callMe, and inside F, inside the class F, it is defining inside F callMe. Now we have this testing class dispatch. So inside dispatch, we are creating three objects of D, E and F, which are A, B and C. Three objects of D, E and F class are created. Now we are creating a reference variable of type D, and using this reference variable of type D, we are accessing the objects of D, E and F. Okay, so what will happen? Let's see. Now here we have the parent. We are making use of the parent class object we are creating a parent class object, and that parent class is made to point to A. So we have the type. We have a reference type of type D, and we have the objects of D. We have the object of D, which is A. Then we have object B, which is of type E, and we have C, which is of type F. Now we have this reference variable of type D. Now we are making R point to A. So we are when R is pointed to A, then we are calling call me. Okay, so A is of class type D, right? A is of class type D. So which method will be invoked? The call me method of D will be invoked. Okay, even though here D is R is of type D, and D using R we are pointing to D object only, so there is no issues here. So here it will definitely invoke the call me method of class D. Now in the second and third case, let's see what will happen. Now what is R? R is the object of class D. Is the reference of class D, and using that R, we are pointing it to D. So now where is R pointing to? R is pointing to D, and using that we are invoking. So R is pointing to B. So and again we are calling R dot call me. That means you are making use of the parent class reference to call the child class method. Since R is pointing to B and you call me, then it will invoke the method which is defined inside E. So this will display the statement inside E's call me. When here at this point, it will display the insides D call me. So we get this line in the output. Now in the second case, we have R is pointing to B. R is made to point to B, and from using R, you are using even though it is pointing to B, R is of type D. So even though it is of type parent class, which is made to point the child class, and you are invoking call me. So this call me will be the version of the call me which is defined inside the child class. So inside child class, you have the implementation is to display inside is call me. So you get this output in the statement, this statement in the output. Next we have R is made to point to C. So R is pointing to C object, and you are invoking call me. So now since R is pointing to the C object of class F, R dot call me will invoke the call me inside F. So it will invoke call me inside F, which is printing the inside F's call me method. So you get this statement in the output. So this is the working of dynamic method dispatch. Okay. So here what it is doing, here at runtime, these methods, even though we are using the object reference of the parent class, at runtime it will be invoking the method it will be invoking the methods to which it is pointing to, right? So here in this first case, R was pointing to the parent class D. So what the call me method will be the version of D class. Now in the second case, it is calling the it is pointing to the B. So in the second case, it is pointing to B. So here it will be invoking the call me method inside the E class. And then in the third case, it is pointing to C, wherein C is of class F type, and r.callme will be invoking the F's call me method. So at runtime, whichever version, to whichever object is, that our reference is referring to, based on that object and based on that type of object to which it is connected, that particular method will be invoked. So this is about DMD. Now let's look into one more example of method overriding. So here we have a class named figure. Inside that figure, the instance variables of that figure are it is having two figure. We have, like, this is based on our example wherein we have the figure and we need to find the area of one figure. Okay, inside that figure class we have an area method. So this figure class can be used to find the area of either a rectangle, square, circle, anything which we want. Okay, so here we are finding the areas of a rectangle and a triangle. So inside the rectangle class, this is a rectangle, and inside the rectangle class we have the method area, and inside the triangle class also we have the method area. So here, this whatever method was available in the parent class figure is overridden inside the rectangle and the triangle class. So here we have for the figure we have two instance variables which are dimension 1 and 2. So those will be available here also. This is and 2. Here also we'll have 2. These two variables will be available in the child class also. So here we are making use of the figure constructor to initialize the values of dimension 1 and 2. And we have the statement area, wherein since this figure can be any type, there is no formula which is particularly used for this. So we are saying that this area is undefined. So inside the figure, the method will, if you call the area of the figure class, then it will be stating that figure area is undefined. Now we have from the figure class, we are creating a rectangle class. So inside the rectangle class, we are invoking the super constructor to initialize the values of rectangle sides. The sides of the rectangle are initialized by invoking the superclass method, superclass constructor. So you are calling super AB. So when you call super AB, this will be invoking the constructor of the superclass, since rectangle is inherited from figure. And to find the area of the rectangle, we are printing the statement inside area of rectangle, and we are finding the area using the formula length into breadth. Okay, so length and breadth is here represented by dimension 1 and 2. Variables dim1 and dim2. Yeah, so inside area we have this implementation for rectangle. Now inside the triangle class, when we have inside the triangle class, you have again here we are invoking it is half BH. So we have to initialize the breadth and height. So to initialize the breadth and height, you are invoking the super constructor. You are invoking the super constructor to initialize the breadth and height of the triangle, and we are having the area method which will display, which will return the value of half BH, and that is it is implemented in another way inside the triangle class. Now here we have a class named as find areas DMD. We are creating an object of the parent class and the two child class. So we have figure F for this thing, and rectangle is set to 9 and 10, and triangle is set to 10 and 8. Now we are creating a reference variable of figure, and then that figure is pointing to R. So when figure is pointing to R means that figure object is pointing to rectangle, And then, so we have this figure object pointing to rectangle. We have figure. We have the figure reference object, and we have two objects of rectangle, which is R, and the triangle, which is T, right? Now, first we have this figure pointing to R. So when you invoke figure.area, it will invoke the area method of the rectangle. So inside area method of the rectangle, we have inside the area of rectangle and return half BH. So you get return BH, product of the two sides. So we get the output inside area of triangle, and the sides of the rectangle are 9 and 5. So 9 into 5, we get 45. So here again, we are making use of the parent class reference to invoke the child class method, since this parent class object is made to point to the child class. Next, we have this figure. Now we have this this reference object made to point to the triangle object. So we are making it to point to T, and in that, again, you are calling figure.area. That in turn means T.area. It is invoking the T.area. So inside T.area, we have we are having inside area of triangle, and it will return half BH. So you get the statement inside area of triangle, and half 10 into 8, we get it as 40. Now figure is pointing to F, which is the parent class, and this is invoking figure.f.area. So even if you call it like this, it is basically calling f.area. So f.area means it inside f's area, inside the figures area, we are implementing the area as figure area is undefined and it is returning 0. So you get figure is undefined and the area is 0. So this value will be 0. So this is about method overriding, wherein the parent class, the methods in the parent class can be overridden in the child class, and the child class can implement those methods in its own way. It can give their own implementation for that child class. So that is method overriding, and also here we have the ability of implementing dynamic method dispatch using method overriding. Now, to prepare all these slides, I have made use of the text complete reference of Herbert Schild 9th edition, and also I have made referred the website of these two websites for preparing the slides. So in today's class, we have discussed about preventing inheritance using final, then the object class and its methods, and about runtime polymorphism. So that is all for today. Thank you for watching my video. We'll continue in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.